Hi, I'm Cannon Lockburner,
I'm Andy Ompron.
and we are the inventors of the Washer Watcher.
So we noticed a major problem at a lot of colleges and college campuses. A lot of the times the laundry system is inefficient, and a lot of times you'll have people with laundry stacked up or people taking forever to move their laundry. So that's why we invented the Washer Watcher. So this will be primarily aimed for the universities. Those will be our main customers, but it'll be a lot of students and maintenance crews using this to help speed up the laundry process. And so what we're gonna do is have a display, an LCD display that will show how long it's been since the machine is done running. And also it'll have a shake sensor, so if it's shaking too violently, it'll display a message that it should be checked for maintenance. Yeah, that's it. Okay, so as you can see here, we have the LCD screen that says on, and then this is like our mock laundry machine. When it's running, it senses movement, and it says running. And then once it stops, give it a second, it'll start displaying the time since the machine's been done for. And then also, if it's really shaking, it'll display a check machine error warning, so that way it can get serviced.
All right, and then I'm going to show you guys the wiring diagrams, the flow chart, and then demonstrate exactly how the code works. So this is our wiring diagram. We have our MPU, which is wired up, our tilt switch wired up, potentiometer wired up with the LCD. Alrighty, and then this is how our code kind of functions. So first it's gonna check if the MPU is connected. If not, the LCD prints nothing, and you know you have a wiring problem that you need to go look at. If it does, the LCD is gonna print on. From here, it'll check the sensors. It's gonna check if the tilt switch is activated. If the tilt switch is not activated, it'll just check your MPU. If your tilt switch is activated, your B is gonna go up by 1. B is just a placeholder variable. And then if B is greater than the allotted major shakes, which would be an indicator of the machine being broken, the LCD will print check machine. And then it'll get stuck there so that it can't, start running again while the machine has sensed damage. All right, if we check our MPU and is it shaking and it says no, we're gonna take a T2 second timing, and then we're gonna have our diff set to T2 minus T1, and then it's gonna measure is the diff greater than the allotted time and is T1 greater than 0, signaling that the shaking has begun. If not, check the sensors and wait for it to shake. If it does shake, it's going to take that T1 and print running, back to check sensors. Not shaking, diff is T2 minus T1. Diff is greater than the allotted time and T1 is greater than 0, then it will print that the load is done and the time since it was completed. And because the washing machine may take some breaks throughout the time that it's running, it has a mechanism that will resense shaking of the MPU and allow it to print running again in case it has falsely sensed a stop in the machine. All right, and then finally, we will take a look here at our final code. So we've got everything initialized, MPU starting up, LCD, yada yada, all our variables and stuff. And then void setup, 0 begin for debugging, including our libraries, everything. This is the major part. It initializes the MPU and it prints that. And then if the connection is successful, the LCD prints on. If not, failed, it will print that to serial monitor and the LCD will just remain off. This is our shake sensing. If it is sensing shaking, it does the running, and then sets T1 to the current time. Else, this is for debugging purposes, prints still to the monitor. It'll take a T2, and then if that T2 minus T1 is greater than 6 seconds, or you could really do any amount of time pertaining to your specific machine, clears the machine, or clears the LCD, done for on the LCD, and then it sets check equal to 1. If the check is equal to 1, it displays the difference in time. below the printed done for. And then if check is not equal to, or if the machine starts shaking again, it sets check equal to 0, so this time disappears. All right, and then here is the brake sensor, I suppose. So if the tilt pin equals 0, it's going to start at 1, so therefore if the tilt pin deactivates, it'll hit 0. B plus 1. If B ends up greater than, in this case, 15, but this could be any allotted number of shakes, it will tell you to check the machine, and it has no backout. Yep, that's code.